Disconnected. Did you unplug it?
Which one?
Did you unplug it? Because it's not... it was working a few seconds ago.
There's a problem with the video? Video?
Right, let me restart it. No. It says disconnected. Well, it was working a few seconds ago. Let me reboot. We'll see. Yeah.
Oh, start again?
I'm rebooting to just make sure it's okay.
No, the video is not coming out.
He said he switched it off.
But I turned it on. I kind of turned
it
it
on and now there's no image.
Yeah, it says it's disconnected. Anyway, let's see.
Yeah, well, he started. He's up.
About to find out.
For some laptops, the external monitor, the beamer should be in while you're booting it, otherwise you don't recognize it.
Yeah.
I'll just leave it in and see what happens. Sometimes your OS does it. I don't know, my laptop, I think it's a hardware thingy. I can't remember the music you were playing, but now the Star Wars tune is stuck in my head.
No, that was recast there.
Oh, then it's just probably my head.
Man, I don't understand. It was working a few seconds ago. No, that's not good at all. Oh shit! What the fuck?
Yeah, we point, take a camera and put it on the left. It will not work.
Let's try it.
It would be a pity because looking forward to stuff.
Well, worst case, if your laptop doesn't work, could you put your sheets or your demo on a USB stick? For instance?
Yeah,
There you go.
that was the.
No, just signal.
Yeah. Oh, very good.
Okay.
Okay.
But I don't have it.
Yeah, and then you cannot see here, but leave it. You can just.
What did you do? You pressed.
That was this one.
Yeah, you switch between the two. Probably you cannot do it at the same time. Often that's the case. You have one.
Yeah, but it only works at boot time.
Either one or the other.
Oh well, create extra. There's nothing there. Yeah, that is great.
But say if you don't get this to work, it's easy to run this on another system.
Yeah, as long as I got my half for. Man, that sucks. It was working just a minute ago. I understand.
What kind of system do you need? I could, for instance, take my laptop.
Linux system, but yeah, a Linux system with SSH. Let's pick there. Ah, there we go. Got it. Man, go find out.
Hello, everybody. Welcome to the last talk for this tent. At the end, if you're sticking around, I'm going to ask everybody to grab a chair and put them in the back when we're done. But for first, let's get to our last talk. Our next presenter is going to be talking about sniffing cable modem traffic. Speaker is Guy Martin. Here he is.
Hey. Thank you. So, hi, I'm Guy Martin. I'm from Belgium, and I'm going to talk about sniffing cable modems. So here's what I'm going to talk about. First, I'll do this in two parts. First, the theoretical part, let's say the boring part with how it works, etc. And then I'll do a demo and show how it works and how easy you can sniff those packets. About the talk, the agenda, what is DOCSIS? So a brief description of the protocol, the architecture, how the modem registers, etc. What's the available encryption. Then the meat of the talk, how to sniff it using the DVB-C card and then using the Packetomatic. Some security concerns. There's few tricks and stuff we can do, which are really funny. So I'll talk about the privacy, the impersonating somebody, SNMP tricks you can do, and some other stuff you'll see, and also the reference. All right, so what is DOCSIS? Well, DOCSIS, that stands for Data Over Cable Service Interface Specification, and it's got mainly 3 uses. Internet, well, that's obvious. Everybody connects to the internet with this cable modem. But it also has 2 usages which are less known. Telephony. For example, some ISPs, they land cable modems with phone plugs with ATA built in. Those ATA, they usually have an IP address on a private range which you cannot access, and it's like a separate system, but it's built in the cable modem. You plug your phone and you place phone calls as if it was your landline. And also digital TV decoders. So those set-top box that you get from your telco, well, from the TV company, if you want to buy a movie or something, the way it works is that additionally with the TV tuner that you have in your set-top box, you also have a built-in modem which talks HTTP or whatever to your TV company, and you can order movies, watch them, etc. It's also known as VOD for video on demand. So the general architecture of a DOCSIS network, it's really basic. On the ISP side, you've got what's called the CMTS. So it's the cable modem termination system. And it's the way it works is that it broadcasts packets on one frequency or multiple frequency, but that's only for the latest version of DOCSIS, which can do channel bounding, so it uses more than one frequency to get more bandwidth. It's like 802.11n. For the upstream, it's the other way around. So each modem sends back on a lower frequency, which is usually around 50 megahertz. And this is time division multiplexing, but it's kind of weird because they do funky stuff with the QM, the QPSK, and also anyway, it's details you don't want to know. The modem on their side, so they use a time slot, and this architecture can serve from a small neighborhood, let's say 100 person, or more bigger cities. You usually have more than one CMTS in big cities, but for one CMTS you can see like 500 person, maybe more, depends really. I've not seen more than 500 so far. There are 2 particular things about DOCSIS itself, is that it was designed in a way to be very compatible with the existing equipments of digital of TV companies. So for example, the actual packets are encapsulated in MPEG payload. So it's just like MPEG TS stream. You can dump it easily, and for example, the repeaters can send them back as well. That's very common. And it uses the same ranges as the TV frequencies. So usually what the ISP do, for example, if you buy internet and not the TV, they put a filter which allows you to only get some specific frequency where the DOCSIS frequencies are, and they filter out the TV, and that's it. But it's really almost the same, at least for the downstream part. The upstream is a different thing. So that's for the architecture. How does the registration process? So when you boot up your modem, you plug it, what's going to happen? First, it's going to find out where is the DOCSIS frequency. How to do that? Well, easy. Start from bottom, go to the top. It's going to look at every single step, all the megahertz. And if once it's able to tune and it's got some locks, it will check the payload. And if payload looks like DOCSIS payload, well, that's it. It's acquired. You got the downstream. Now, to get the upstream, you have to wait so that the ISP broadcasts some DOCSIS frames with the actual upstream parameters, and then it's going to tune to that frequency with the right timing, the right time slots, and all services, etc. And that's it. At this point, you have both ways established. Then you establish you get an IP simply via the HTTP, send the HTTP request, get the IP back, and that's it. Very easy. In that DHCP response, you also have the TFTP server address, and that's very interesting thing here because that TFTP server address contains the configuration for the modem, as in all the SNMP ACL, so who can access the SNMP server on the modem, all the IP filters, what's going to be your upload and download limits, the bandwidth, all this kind of stuff. And also the configuration for the phone system or any other things it may need. So once it's got this, it will apply the configuration downloaded via TFTP and enable IP forwarding. As a general rule, I mean, the modem itself, it's really a bridge, a really stupid bridge, which only forwards all the Ethernet frame that you send on the LAN end to the cable end. And that's useful. We'll see later how we can exploit that. The only filter that there is when it first detects a PC, which is plugged on the modem, it will recognize that MAC address and only let that MAC address pass. So, depending again on the configuration, you can have more than one unlimited, but it's usually one. Of course, well, it's not secure, so people thought, oh, what about we encrypt this thing? Which is a good idea, but it's of course not mandatory, so people don't implement it because it's much too overhead, etc. So you'll find lots of cable company which don't run encryption at all, and well, I find it very scary. You'll see why. The encryption, it's called BPI, Baseline Privacy Interface. There are multiple versions of this encryption mechanism. There's BPI 1, in DOCSIS 1 there's the BPI, which was there just like it exchanged the key over some specific DOCSIS packets, and then it encrypts the payload. It's triple DES or DS, I'm not sure because the specifications are not clear in that. Sometimes I read it's DS, sometimes I read it's triple DES. Anyway. Doesn't matter, it's really easily crackable. Also, in DOCSIS 1.1, they found out that, well, it's kind of easy. You just go with your rogue modem, change the MAC address, plug it on the cable, and that's it. You're connected, and your stuff is encrypted. So they added certificate authentication. So the modems have built in a certificate from the manufacturer. It can also be downloaded in the modem. Via TFTP, etc. However, again, some ISPs, they're too lazy to check their config, and they accept self-signed certificate. So what you do, you create your self-signed certificate, put it in the modem, and boom, oh, connected. Cool. That's nice. So, yeah, they found as well that triple DES, well, it's nice, but it's not really secure. So since DOCSIS 3, they provide AES. However, AES, it's really computational hungry, so it takes a lot of CPU resource. And for AES, you need a specific chip on the modem to do the hardware encryption. But this chip costs a lot. So, well, the customers aren't ready to pay for something they don't even know about, and ISPs won't deploy it either. So nobody's running AES, actually. For example, DOCSIS 3, most of the modems right now that you can buy, they don't have AES encryption. It's triple DES only, and that's it. Notice there is interesting part. So, how can we sniff this? Well, let me just tell you the story. I was like trying to debug my TV card and see if I could have it working on Linux. And, well, it wasn't working. And then I decided to try it on Windows. Well, okay, install Windows, blah, blah, it's boring. And, I tuned to some frequencies, couldn't find anything. And then I tried the modem frequency. And, oh, hold on, I got packets. I got MPEG packets. What the hell? What is in those packets? Interesting. Let's see. So I went on Google, my dear friend Google, and I asked him, oh, what about DOCSIS specification? And whoa, all public. Ooh, interesting. So I spent a few nights reading those specifications. My girlfriend was very happy. Hi, by the way. And I found out that it's really easy to de-encapsulate. You take the MPEG packets, look at the marker, and put everything back together, and that's it. You get DOCSIS packets. And in those DOCSIS packets, it's like a very short header. You got Ethernet frames, and, well, Ethernet frames, that's it. You can use all the tools that you use, like Wireshark, everything. It took me about, like, 24 hours between the time I had the idea. I was like, oh, yeah, let's sniff that. Let's see what's in. And the time I was able to actually read at packets. So, again, it's a really easy thing. Regarding those cards, those DVB-C cards, it's really... it's simply a TV card that you can buy anywhere on the internet. On the wiki, there are a few lists of cards which were better than others. But in general, if your card is supported on Linux, you can sniff your cable neighbors. There's only one downside on this, is that you can only see the downstream. Why? Simply because the upstream, it's like that funky TDM, QRM, and weird combination. But the downstream, well, it's enough data, a lot of data, actually. Also, I'd like to try USRP, but it's kind of expensive, and I'm afraid that if I buy that thing, my girlfriend won't see me again. So I think it's possible. I just have to try it out. And also DOCSIS 3, that uses multiple frequencies, as I said before. So you'll need more than one card. However, I haven't had access yet to a cable with DOCSIS 3 enabled, so I don't have support yet in my tool for DOCSIS 3. But if you have multiple cards, if you have access to DOCSIS 3 network, and if you give me access, I should have it in no time. All right. So I developed a tool for that because it's nice to sniff packets. You got like 5 megabytes per second, and you're like, okay, what do I do with all this data? You start Wireshark with your 1 gigabyte dump, and it takes forever to load. You try to search for something. Well, it's too slow. So I decided to go the hard way. So the easier way would just be to give some rules, dump this, dump that, and put everything on files. And that's what I've done. The way it works is that you simply select an input module. You say DOCSIS or PCAP because you can read from files, whatever. So, but in our case, we're going to focus on the DOCSIS one. Then the packets are processed and matched using rules that you specify, like TCP port 80. Port 21 or UDP and RTP. You can really do a lot of things. Once those rules are matched, the helper and contract modules are going to take place. The hard thing here was that you got lots of packets, but for example, you got TCP packets, they cross each other, etc. And I had to put this all in a nice way, one after the other, so I could simply take those packets, dump it in the file, and done. So that's done. And then the targets, so it's 3-step. Input, then rules match the stuff. Helper, there's a bit of magic there to make sure everything is fine. And then it sends that to the target modules. And the target modules, well, they do dump the images out of the HTTP stream, dump the RTP, etc. And of course, there's a telnet and XML RPC interface available. Let's talk now about the security concerns. So privacy, well, we're all concerned about our privacy. Of course, if you can sniff the packets, you can sniff everything that people download. So as I said here, reassemble all the streams in real time, extract everything, the main. Of course, since there is a phone plug on your modem, well, that voice is going to go somewhere. Well, it's going to go on the cable. And where does it end? In my TV card. So I just listen to it. IM conversation, let's say, do you guys use Facebook? I don't, but if you use Facebook chat or everything, you know, it's both ways. When you type something, it's sent back to you. So you see the whole conversation because it's all in the HTTP stream. Also, all the images that people go and download. Yeah, I found out, you know, I was like, yeah, let's download and look at all the images that people go and see. And yeah, I was kind of surprised because I found out there were a lot more gay people than I expected. And I decided to stop that. Yeah, that was funny. Yeah, my neighborhood, but I don't know them. So, yeah, of course you can sniff, you can find out other stuff like the Google search that people are typing, you know, because that nice auto-completion thing you type and oh, it gives you back everything. Or, yeah, the Facebook images, well, I said that already. I got a friend who's got like, yeah, that's funny. He tried that once to just dump all the images from Facebook and he's got a screen. It's like, oh, look at my friends. And every second he's got a new picture coming up. That's cool. So what can you do about this? Of course, use a VPN tunnel to a trusted endpoint. So, well, you'll just encrypt whatever is in that endpoint in your cable modem, but at least that I won't be able to sniff you. And use encrypted protocol, SSL things. But, yeah, as we've seen, SSL is kind of flaky nowadays, so I'm not sure it's a good idea either. And, well, the best thing would be that the ISPs just enable BPI. Please do it. If you are an ISP and you are in this room or you're listening, just please enable BPI. It's so scary. All right, so there are some more fun stuff we can do. Impersonating. Well, you can simply, you know, your modem, it's a stupid Ethernet bridge, right? So let's say you sniff all the connections on your PC, and you got one TCP packet. Oh, well, you can forge the TCP reset, send it back through your modem, because as long as it's got the right MAC address, the right source MAC address, the packet is going to go through, right? So the IP address can be whatever. It's not going to be checked by the cable modem, and poof, that's it. You can, well, if you're like on Monday morning and you want to download faster and you see that everybody's using BitTorrent as well, just kill them all, and it goes a lot faster. Or if you like, you know, that no MSN day, well, TCP port 181563, reset, poof, bye. Yeah, that's funny. You can also use someone else's IP address. There's a very cool thing with Windows. There are a few, but there is one that its firewall, it just drops everything. And in this scenario, dropping everything is a security problem. Why? Because if I come with my modem, or I take somebody else's IP address, and with some kind of funky configuration, you start sending packets with that IP address from your modem, from an ADSL modem, from anywhere on the internet. The packet, so let's say you're in the street, cable, TV cable, plug your USB digital card, use your cell phone, sends packet with an IP source of somebody on the cable, and that packet is going to come back over the cable. So if you want fast download, spoof that IP address, send all your stuff via the cell phone, and retrieve everything from the cable. This is also not good because, of course, you can do whatever you want. You can I don't know, all these things, they're not nice. So if you have a cable modem and if you drop everything, just try to send TCP reset or ICMP unreachable for UDP streams, because of course I could tunnel something and again. Again, the workaround for the ISPs, enable BPI, please. Some funny stuff in here. SNMP tricks. All right, so, well, the modem replies on, there is an SNMP server on the modem, but, well, it's not accessible by you, of course. If you try to send a request with the public community, that won't work. So what do you do? Well, you sniff, and at some point, the ISP is going to check what's happening in your modem. For example, it may want to tune a bit the time slots, or make sure you got the right power levels, etc. But that's easy. Once you got that single packet, it contains what? The IP source, and also the community. So, well, what is the modem again? A stupid bridge. You send it from the Ethernet interface, and the modem is going to reply to you. All you have to do is sniff the source IP address. And, okay, now that we got access, what can we do? Well, in Belgium, where I come from, there are limits on the amount of data that you can download per month. So you are sometimes limited to 10 gigabyte, 30 gigabyte, and it's definitely not a lot. So what do you do? Oh, well, you tell the modem not to reply to the server which checks the counter on your modem. And it's like your modem was offline. And that's it. 300 gigs per month, more if you like. Don't abuse, though. Yeah, you can also reboot the modem. Oh, by the way, if you have access to your modem, you have access to all the modems in your range. So you can do anything. Reboot the modem, change its MAC address, I think it's possible via SNMP. Well, whatever you think of. And if you're bored enough to read all the SNMP specifications on DOCSIS. Yeah, so the workaround again is first enable BPI in order not to be able to sniff that packet, and also make sure that you cannot access SNMP via that you can access SNMP only from the coaxial interface. However, that's also a little problem because if you have two modems, well, you connect to each other, So you just find a friend and that's it. Okay, some more funny stuff. That was... let's say you want an SMTP server at home, so port 25, but obviously it's blocked. You cannot receive anything from on the port 25 because there is a rule in the modem that says, oh, everything destined for port 25, drop. So, well, first, if you're able to get SNMP access, just disable that filter, and it's easier. But if you're not, what do you do? Well, it's really easy. The modem only look for IP packets with destination port 25, not source port 25. That means that you can send out packets with that source port but not receive them. Well, what do? You take your PC, you take your modem, you receive the packets on port 25 from your PC, re-inject them right after the modem. It's going to reach your gateway, and, well, that's it. You get 24 open. And you can resend it back to, you can send the upstream back to the modem. Really easy. Yeah, with the Packetomatic, you can also create a tap interface, just, to have a virtual interface with all the Ethernet packets, and you can use Wireshark and all the tools like dsniff or all you like. And again, the ISP workaround, please enable VPI. Oh, I found that one I was really, really bored. But I said earlier then the cable, the set-top box, they've got a modem built in. So when you pay for a movie, say you pay €9, €5, I don't know, whatever, you pay for it. But that goes through the HTTP interface. You say, hi, I want that movie, and the ISP says, sure, there you go. But here are all the parameters for you to check, to actually see the movies. Here's that frequency, that MPEG PID, etc. So what do? Well, you take your other PC, you take your other TV card, and you tune to that frequency, and you watch everybody's movie. It's a lot of movies, huh? But again, work around, encrypt the MPEG stream, and enable BPI. But it's pretty easy to do. It's just they're too lazy. The references, so cablelabs.com and cable modem for all the specifications. The MPEG specifications for the actual payload and Pagamatic. But yeah, let's come back to this later. Let me show you first how it works. No, let's connect to, oh, okay, of course, I forgot to start my internet. Give me internet. So what I'm going to show you is how easy it is to sniff on, to actually find the frequency and sniff those packets. Oh, sure, sorry, just a second. Wait. Okay, hold on. Why am I not seeing anything? I hate when it does work like that. What the hell? What's the command again for Xterm to get a bigger font? I thought I could just right-click and get a bigger font. Control-Delete, right. All right, let's just start it and then... come on. Don't do this to me. Man, that sucks. I thought Control-Shift+ would do it, or Control-Alt+. Yeah, Control right-click, but when I do that, it kind of freezes. And there you go, no, nothing. It's just... Oh, man. Maybe if I just switch the resolution. Let's read the damn manual. Somebody knows it by heart. I'm worried. Oh, man. Sorry? Yep, I tried that one, but it doesn't want it. Sorry? Yeah, okay, well, I'll find out later. Can anybody read, actually, or are you all, is it really, really too small? No, I'm sorry. Oh, that's a good idea. If it works. I just don't see anything on my screen, but that'll work. Nope, wrong IP address. Yes. All right. So this is what I got. I just start tool. So it started here. Oh, I'll restart it. Okay. I connect via telnet. There I am. Yeah, apparently we can't see the left hand on the screen, but it's okay. All right, let's look for a DOCSIS stream. Input, type, set, DOCSIS. Okay. And input mode scan, mode set scan. So here, if I just do input start now, it will search for all it will start from the bottom to the top. So I know the frequency by heart. What I'm just going to do is set the frequency to a closer, so it's start frequency, and I set it to, let's say, 330 megahertz. Let's put it more verbose so you can see Dvox CLI set 5, no 4. Come on, input start. There we go. So here we go. It's trying to tune to all the frequencies. It started by the one I gave, which is 330, 331, 332. Hopefully it's going to find something. It's not going to take long. We skipped it already, but before... Oh, see, it found something, but so it logs. But it's not able to find any sync messages, which are the DOCSIS specific messages. So it just skips this one and goes to the next one. Yeah, actually, it's kind of far away from the right frequency. So let's... Not sure if you guys want to wait, but I don't, so... That's going to be up 439, nothing. 484, 440, nothing. 441, nothing. And there we go. Eventually, 442, it's got everything. Find the sync, and that's it. Let's see. Input show. Ooh, already 35 megs. 46. 49. Well, let's check. So that's it. All the packets are being received. I can do everything I want now. Let's say, well, I want to actually see the traffic with the tool that I often use, which is called IFStat. So I will create a virtual interface and dump all the packets that I receive on that interface. So I will first add a rule add, and I'll take all the Ethernet packets. Very easy. Then I need to... enable that rule and add a target. Add, what is it? Yeah. So I add target to the rule 0 and its target tap. Now I start that target 0, 0, and there we go. I should have, so if I do target show, as you can see, it's the interface name POM0. Up, I turn it on. And let's see. Oh, okay, 2 megs per second. It's okay. It's not that much, but so there are a few. Oh, by the way, I forgot to say that this is at my place at home in one of my computer in my room. Let's see what we can do. Are people calling right now? Well, let's find out. So as I said before, the ATAs and the modems, they've got a specific IP range, so we can just, I know it by heart, like we can, you can use Wireshark, find it out, but let's add a new rule add, and that's going to be IPv4.source equals 10.127.0.0/16. And we're going to take all the UDP and RDP packets. So here the rule is first you specify, you have to specify all the protocols that you want to match in order. For example, if you want to match IPv4, IPv6 TCP packet, I would have written IPv4, IPv4 pipe, IPv6 pipe, TCP. And in this case, I want to match all the RTP packets. So as you know, the RTP packets, they contain the voice payload. And it's encapsulated over UDP, so I just say IPv4, I specify the source, which is 10.127/16, UDP, RTP. So here, as you can see, it registered all the needed connection tracking modules and all the helper modules. So if you don't receive the RTP packets in the right order, that's going to be taken care of with that module. So you don't have the, you hear hello. And of course, add the target. So target RTP. No, first rule 1 RTP. Target parameter set. Let me show you. So target show. I got 2 targets. Prefix, that's where I want to dump the calls. So target parameter set. Rule 1, target 0, prefix /TMP /calls. No, RTP calls. Start the target. And enable the rule. Before I do so, let's go in that directory. Create it. Well, it's not needed, but boom. There are here 1. That's okay, but oh, somebody's calling. I don't need all this debug. Oh, come on, just 1 call. Please, call some more. Use more bandwidth.
Call your boss.
Hey, guys, I'm not using that, huh? I'm not crazy. Usually there are like 5 calls. I guess everybody's sleeping on Sunday or something. Well, as you can see, so the size increases because that guy is still calling. And, well, you could just play it. However, there is an additional layer of security, is that those guys in my neighborhood, I don't understand them. They don't speak French or English, so... No, I'm just kidding. All right, so that's one thing. I can show you a lot more stuff, but I'll do it on my laptop because I don't want to mess with this. So I'll just stop this. 4 errors. Well, that's okay. And I'll switch back to the X if that works. Yes. All right. Let me show you some more. Sorry for the small console, but you got the idea. Hopefully some people can read. So I'm just going to start it with an empty configuration. What the... Of course. Okay. This time I'll use input pcap, so input type set pcap. If I do input show, you can, if you're able to read, see that it's using ETH0. I'll just start it. Input. So that's on my laptop. I'll mess with myself. So what can I do? All right, do you guys want to see the images? Well, let's start this. Target add, rule add tcp.sourceports equal 80 and enable the rules. So rule enable 0 and add the target. So target add 0 HTTP. Target parameter set. Okay, so what do we want to do? Oh yeah, let's configure one additional thing. There's also support for databases, so because it makes it easier to parse the data. Data store add SQLite supports multiple stuff, and target parameter set. So I'll just say to dump all the log files in that database and also in a text file. This way we got both. So I set the log file to /tmp http.log, and for the data store. So what I did is data store add SQLite DS1. So that just creates a new SQLite data store, and by default it's going to use the pom.db file. There's really nothing else to configure. And in that parameter, I just give him log the data store log path, and I'd say ds1 /http. So it will create in that ds1 data store tables with HTTP prefix, and then all the thing it's dumping. And I'll do one additional thing. I'm not sure if you can see, but DSLog format, that's the same format that Apache format. However, I have added a few tweaks which are useful. For example, you can dump also the passwords, which you can't in Apache. So I'll just change it and add %p and also uppercase. Where is it? Come on. And %f. Just start the target 0, 0. There we go. All right, let's browse something. Oh, I forgot one thing. Need to stop. I'll tell him to just dump the images. So target parameter set dump 0, 0 dump images, yes, and also the videos. Yeah, that would be good. All right, let's have fun now. Yes, whatever. So you guys know that website. I hope you like cats. Ooh, give me that cookie. Anyway, let's see. Oh, we got a lot of images. What is all these? Oh, my cats are here. Cool. So, as you can imagine, oh, that was not the one. So yeah, if I can do this on my laptop, I can do this on the cable interface. And yeah, here we were lucky, we had a nice girl. Well, I wasn't lucky when I tried. And yeah, it works of course for the videos. So YouTube, no, do I have something like, I don't know, Rickroll. Sorry, it was mandatory. Play. Oh no, you know what? I rebooted my laptop and I didn't load the damn sound, so I can't rickroll you without music. All those unexpected problems. Ooh. Yeah. It's plugged, but I guess it doesn't like me. I could sing, but yeah, whatever. Okay, too bad. Well, I guess you were rickrolled enough already anyway. But yeah, the video is of course here. And you can watch it as much as you like. Never gonna give you. Oh, so it works. Yeah, one more thing. Let's check the database. So here, the database should be somewhere here. Select start from HTTP logs. Ooh, all the logs. No, let's just do one more one last test. Man. The basic oath test. So you go here, you test the basic oath, you do click here, test. All right, so I generated some logs. No, let's look. It's really handy. Not sure you can't see. Sorry, but select start from HTTP logs where username is not null. Oh, here we go. Yeah. By the way, I'm not sure if you noticed there is a big antenna at the end of the camping with, well, actually 3 of them. So if you used an encrypted stuff, it's probably dumped somewhere on my hardware, and it's in my database. All right, so I could show you a lot more stuff. I mean, there are dozens of things, but we're running out of time. I'll just go for the conclusions. So before this, okay, conclusions. So as a user, Well, if BPI is not enabled, well, everything's public. Don't even. I mean, encrypt as much as you can. You can also probably go to your ISPs and beg him to implement BPI. And you can monitor your firewall to see if anybody is impersonating you, because you will have all those returns packet. But that's all you can do. The ISPs, please again enable BPI. It's really stupid not to enable it, especially seeing how easy you can all do all this. So you can bypass all the filters in the modem. Then, of course, the ISPs, they use like they put protections to protect themselves with their private IP range. But once you disable that in the modem, you can access all the ISPs box, and well, it's not good for them. And impersonation. All right, if you have questions, it's the right time.
Just on the use of BPI, as you said, the only thing that kept you away from looking at the upstream as well was your girlfriend. So probably a person without a girlfriend or who has a girlfriend on vacation or so on.
I don't have the feedback here, so I don't understand really what you... Can you say again?
I tried. What is the use of BPI? Because the only thing that kept you away from reading the upstream, you said, was you didn't take time for that because of your girlfriend. So a person without a girlfriend, or with a girlfriend on vacation probably, will be able to read the upstream, if I understood you right.
So BPI, it's only about its encryption. So with BPI, you actually encrypt the packets. The problem with the upstream, it's first because it's a different frequency, and the normal TV cards usually cannot tune to that. And also because it's not QAM modulation or QPSK. It's like time division multiplexing. So each modem has a specific slot. They are all synchronized. They send at the right time. And with the QPSK or QAM modulation, so I don't have the hardware for that. If I had a USRP, probably. But even though you would only be able to sniff a few modems, probably only yours. I don't know.
No, I was afraid that you were standing there next year and tell us that you can play the man in the middle and that BPI is useless as long as DOCSIS is accepting self-signed certificates. Because if you play the man in the middle and you accept self-signed certificates, you can give each of the sides your self-signed certificate and repackage everything they want.
The thing with the self-certificates is just a problem with the configuration of the ISPs. They just allow self-certificate to be accepted. They don't have to. So yeah, there is. If you configure it right, it should work. But yeah, you could probably with the USRP code a rogue CMTS. And as you know, the modems they scan from bottom to top. So you go on a lower frequency, all the modems are going to register to you, and you know they always trust the ISP side. Why it's never a good idea.
I had a question. Is there any way, short of sniffing the traffic, to tell if your ISP is encrypting?
Sorry, say again?
Is there any way, besides sniffing the traffic yourself, to tell if your ISP is encrypting the traffic between the cable modems?
Yeah, all the cable modems, they have sometimes a web interface available on 198.162 or 192.168.100.1. And there you can see a few details, and usually it tells you if baseline privacy encryption is enabled or not. But most of the time that interface is disabled, so you cannot see and you cannot know.
Hello?
Do you ever get any packet loss?
What the question?
Do you ever get any packet loss, or can you capture everything?
Oh, it captures everything. I mean, yeah, I'm running this on a via C3 processor. because it consumes nothing. It's like 500 megahertz. It's not even i686. It barely has MMX, and that's it. And at top load, it uses 20% of the CPU. So that's it. All you need is a bit of RAM to handle the ring buffer, but it's about 50 megs. So you can really run it anywhere. The bottleneck here is the I/O, because if you want to save everything, the I/O is struggling, and well, you can't do much about that.
Have you personally asked your provider to enable BPI? And what was their response? Or do you just want to play around?
Actually, I did. And they laugh at me. I called them and say, hi, could you please enable BPI because I can sniff all the traffic? They said, no, it's not possible. Yeah, I said, yes, it is. No, it's not possible. I'll prove it to you. Well, okay, fine, but I'm doing it right now. And, well, I hang up. I was pissed off because, but of course you reach the first line guy and he doesn't believe you or anything. But I know my ISP is crap. I had other issue with them, and I'm not going to name them. But other questions? All right, good. So thanks for attending. If you have some more questions, you can find me at the tent with the big pirate flag and the dual flag. I'll be hanging there, and that's it. Thanks.
As everyone is getting up to leave, if you could really help us out and grab a chair and bring them to the back of the room and stack them up, that'll help us break this room down very quickly. Thanks.